Welcome to this project of Python in which we will be making a Python program for mask detection using the TensorFlow and OpenCV. Now let me show you the demo first. So let me just run this code by writing python.detectmask.video.py, and if you run this program, it will take a while to run the program, and then it's going to open your camera, and after that you can see the image. It defines itself that it is the no mask in here, and until I wear the mask, it again shows me that okay, as a mask guy, like I'm wearing a mask. So we'll be training our model for the same. In this particular video, we will first define the model for the training of the model, and the next video we'll see the Python program for the OpenCV for like using this particular file to detect the mask in the real life, in the real world. So today we'll be defining the file in which we'll be training our model. So for this we need a data set, and we already have a data set with the mask. As you can see here, there are like so many pictures here, and without mask also I have so many pictures. It's just an open source data images which you can just download it from like Kaggle or Google datasets or wherever you want, or scrap it from there. And you need some prototext file and the model file also. Okay, now once you're done with these two, you're good to go. So now let's define the file which is going to be for the training our model. So we'll be using TensorFlow and Matplotlib in this particular file. So make sure that before you run this program, you have all these things installed in this module. For TensorFlow, write like pip install TensorFlow, and for the Python version should be like 64-bit, and Matplotlib similarly just install pip install Matplotlib. It will be just installed in a system. So let's first a code a file. So let's write code train.py. And when we code this file, let's import the required packages first. From TensorFlow.keras.preprocessing.image, I want to import some of the modules. Let's say image data processor, sorry, data generator. And then I need image also, which is image to array. And I also need load image. I need these three from the pre-processing library. Now, from TensorFlow dot keras dot applications import, I'll need mobilenet v2. I'll need this particular one, and after that we need from TensorFlow dot keras dot layers import average pooling, which is going to be to the pooling of the model. So let's go for 2D. We need a dropout. Okay, so we need a dropout, and then we need flatten also, and we need dense also. So how dense like our neural network would be, and then we need input too. Okay, now after that, from TensorFlow dot keras dot models, we need to import the model so that we can like define all our like trained model into a single model file, and from that we need a model, and after that model we need from TensorFlow dot keras dot optimizers, I import Adam. Okay, now after that I need from TensorFlow, it's gonna be TensorFlow dot keras dot applications and dot mobile vnet v2, sorry, import space import. From here I need pre-processing's input. Now after that we need categorical from the imports. So from tensorflow.keras dot utils import import to categorical. Okay, now that's what we want from TensorFlow. Now we want from sklearn. So from sklearn we need, like, so first we need to install sklearn also. So from sklearn we need dot pre-processing. What we want is label Binarizer. So we write import Binarizer. Okay, and from the same module, which is going to be from sklearn only, we also need model selection. We import the train test split. Train test split. So that's what we want to import. And after that, from the metric, so from sklearn dot metric, we want to import classification report. Okay, we need to import this one. And now we know we're gonna, like, import IMUtils. So from IMUtils, we just want to import path, so we can just, like, join the paths easily. And after that, we want to import from matplotlib. So for the plotting the, like, graphs, so matplotlib.pyplot import as, like, write it as pt. Now after that we need from numpy as np, and after that we need import os. Now after the importation of everything, we'll first jump to the logic. First we define the learning rate of the, like, of the model that we are, like, with which we are training, like how to recognize with mask and without mask. And we also need epoch, and that is the number of rotations, and then the batch size. So first let's define all those values. The very first is going to be the initial, which is going to be init underscore lr, which is going to be the initial learning rate. I'll define it as, like, 1.04, which is going to be e to the power minus 4. Now after that we need to define the epoch. So epochs, I'll define it as 20. That will be enough for, like, my data. It depends upon your data, like how many imports you want for data. If your, like, data is big, you can use more epoch. If your data is small, you can use less epoch. And we also need a batch size. So it's going to be BS, and the BSs can be, like, keep it 20. And after that, we need to go to the directory in which our data set is present. So we need to, like, go to that particular directory. And how we go there? We go by this method. My data set is present in C users, and my C user, and then my cousins directory, which is going to be Akash. And I'm going to go to desktop, and then it should write new folder, and after that it's dataset. So my dataset is present in this particular clip. If it's particular in yours, you can have your own link there. And you have two folders. You have with mask and without mask. So we'll have categories, which is gonna be the two folders in which we have, which is with mask and without mask. So these are the two folders which we have in the directory of the dataset. Okay. Now after that, we need to just load the images. So let's give the user give the user update that we are loading the images. So, like, print loading the images. Okay. And after that, what we need to do, let's use a provide or output time to time, so that the user won't be, like, faded out. The user won't be, like, thinking that it should, like, it has been stopped or something. So you need to provide something time to time. So the user believes that, yeah, something is going on, the program is actually running. So how are you going to load the image? So first we need an empty list for the data and the labels. So we'll build data and the labels, and the data and labels as an empty list. Okay. Now after this, we'll just scrapping the data for category and categories. For every category in categories, let's join the path, which is going to be os.path_join.join, and in join which is going to be the directory, and add the category. Okay, so we join the category, and after that we're going to that particular for image in like for every image in that particular category. So for image in os list dir, which is going to be list which dir, the path. So for every image in this particular path, what we need to do, we need to specify the image path. It's going to be image path. It should be os.path.join once again. And join what? Join the path with the image. Now after that, what we need to do, we need to like load the image, and we'll be creating an image variable for that one. So I'm going to call the load image function, and the load image will be loading from the image path. And then it should also have a target size. So all my targets image should have the same size. Let's set the target size to be like 224 into 224. Let's 224, okay, sorry, 224 and 224. Now after this, what we need to do, we need to like convert these images into array. So let's convert this into an array, and we'll store it in the same variable, which is going to be from using the image to array function. Remember the import of this particular function, and it will take the image and it will convert it into an array. And after that, we need to pre-process the input of the image. So it's going to be stored in the same variable. So image is going to be pre-process input, and let's pass the image here. After that, what we need to do, we need to append the images in the data and the category into the labels. Okay, so data dot append what, which is going to be the images, and the next list, which is going to be the labels list, let's append the categories. So category, and after that, what we need to do, we need to encode these labels. So let's jump to the encoding labels by using the label binarizer function for this particular function. So let's make this all function a single variable, which is going to be lb is equal to label binarizer to make an object out of it. Now remember, we like imported the label binarizer by using the sklearn.preprocessing import, and we're going to use the same thing. Now after calling this particular function, we need to we have the labels, and it will be lb dot fit transform, and what we have to do, we have to transform the labels, and after that we need to store that label into the same label list, and it should be two categorical. So two categorical is going to be the function, and we'll be passing labels there too. And after that, what we need is, we need the data. So in the data list, we need to pass this labels as an array. So np array should have a data, and the data type should be like, let's make it float 32. Okay, and after that, what we need to do, we need to pass this np array to the label list. For the data we didn't. Now for the labels also, so np array, pass the labels here. Once we're done with this, now the next step is, let's define the train x and the test test variable. So we need to like have a track of the training and testing data. So let's make it train x, test x, and then train y, and then it's gonna be test y. And after that, these are equal to? These are equal to the train test split function. So train test split function, and we'll pass the required parameters, which is gonna be the data and the labels here, and text size will be the 0.20, and stratify the images. Let's set it stratify. Let's stratify the labels, and after that we'll make the random state. Let me just set the random state as like 42, whatever number you can use. After that, what we need to use, we need to generate the images, like call the image generator function for the data augmentation. So let's call this particular image generator function now by using aug is equal to, we're going to call which function? We're going to call the image data generator. So image data generator, and what it should take? It should take the location range, which is going to be the rotation. Now, not all parameters shouldn't be defining, but few of the parameters will be like default, and then some will be manual. So first define the rotation range first. So it is going to be like set to 20, and after that we need to define the zoom range. So the zoom range is equal to 0.15, let it be, and we need to define the width shift. The shift is gonna be like 0.2. Now after that, height shift range is equal to be, because it's a 2D image, so for that we'll have all the height shift and width shift. So height shift is gonna be like 0.2. And now we also need to like add the shear range. So shear range, it should be 0.15. Now that's the calculative value. You need to play around with this particular values. Or you can just use these values also itself. There's no problem with that. Now horizontal flip also be defined. So let's write horizontal lift is gonna be true. And after that, we need to find a fill mode. So fill mode, it should be nearest node. And after that, so that's it from this augmentation. After that, what we need to do, we need to like load the mobile net. So what this particular mobile net will do, it will ignore the head part. So when we detect the mask, we do not want to convert our head part also. We just need to like up to our nose. That's perfect for the mask detection. So let's like first call this mobilenet v2 function, and then it's gonna help us ignore the help part. Okay, so I'll keep the base model first of all. So we'll just calling this function the base model. So it's gonna be base model is equal to mobilenet v2, and what it will do, it will take the weight. The weight should be like set to, okay, hold on, weight is gonna be set to, so it's gonna be like ways to like ImageNet. And after that, what it will do, it will include the top. We don't need to include the top only, because from the node it's fine. Now from the input, we're going to take the tensor. So all the input tensor, so it's going to call the input function, and the input function should have the shape, and the shape, I'll be passing the height, weights, and RGB values. So height as 224 as usual, because we are set it to, and the RGB value is gonna be 3. Okay, now after that, what we need to do, now we need another model which is gonna be override this override this model as a mask model. So a mask model is on the top of this model, so we need another model, and I'll just call this a head model. And what it will take, so it will take the base model output, so base model dot output. And after that, what it will do, so we'll like this head model, so it will call the average pooling function, which is an average pooling 2D, and it will set the pool size, and in this the pool size is gonna be like 7 You're gonna be the 7th width and the 7th height. And after that, all the changes here will be changed in the head model only. Now after calling the calling function, it needs to flatten the image also. So head model, call the flatten function here. So call the flatten function here. So after calling this flatten function, we will set the name flatten. Sorry, name is going to be flatten, and again we'll just call the head model function. Now after that, we need to define the density of the model. So we'll just call the head model again. So head model is equal to dense function. It will give the parameter as 128 neurons, and after that, activation should be like the relo type. So relo pooling will be using. Okay. Now after that, once again we need to add the head model here. Now after that, what it needs to do, once again head model, it should be equal to to dropout. So we'll be calling a dropout function here, and we'll be getting the values, which is going to be 0.5, and once again add a model here. And after that, that's the last thing that I think, it should go to dense of the upper model. So once again I'll call the head model, and once again I'll call the dense function here, and now I'll be giving the value of the 2 neurons, and the activation should be completely different, which is going to be softmax. So softmax, and once again head model here. Now after this, what we need to do is that we need to define the actual model. We define the base model, we define the base model first, and then we define the head model first. Now what we need to define? We need to define the actual model with the mask. So how will we define that? We'll just call the model function, and we'll be giving the model as the base model and the output as the head model. So let's see how we can do that. We'll make a model variable and call the model function here. We'll call the model function here, and in the input, what we need to do is that we need to give the base model input. So base model dot input, and in the output, what we need to give the output as head model. So output would be head model. And after that, once we define our model, we need to define a loop so that it should not update the images during the training process. So let's first define the loop for that particular process. So for layers, so for layer in base model dot layers. So that's the base model, and it should not update the images. So layer enable should be false. It should be set to false. Now after that, what we need to do is that we need to compile these images, or compile our model. How are you going to compile it? First of all, we'll give the user the messages. So let me first write compiling model, and after that, the message to the user is going to be, we need to call the addom function here. We need in this particular thing, we need to call the addom function here, and we'll be needing to pass some of the parameters like LR. So an LR should be initial, and I guess you know what is LR. So LR is the learning rate. So we need we define the LR here at the very beginning, and which is gonna be 10 to the power minus 4. So we'll pass the LR here. Okay, sorry. So I don't know where it came from, but let it be. Okay, let's see. After learning of this learning bit, what we need to pass? We need to pass the decay. The decay should be equal to init LR and divided by epochs. Should be the decay. So it should be the initial learning rate by epochs. Now after this, what we need to do? We need to compile this model by using the compile function. Let me just run the file, and with this we'll be like compiling first with the loss, which is gonna be the binary cross end, and okay, cross entropy. And optimizer should be up, and metrics should be accuracy. Now after that, what we need to do, we need to train our head model. So for now, let's jump to the training model. So first of all, let's print the user message, which is going to be print. Let's training model. Now after printing the message, we need to train the model. And how will we be doing that? We'll be calling the model.fit function here. So let's define the variable as h. So let's call this model.fit function here. So after this, we need to pass the parameters. Now first of all, let's pass the augmentation loop. So let's pass the aug flow. It should be the train x and the train y and the batch size. And the batch size, what is the batch size? We have defined the batch size in the earlier in the very beginning only, which is going to be BS. So let's pass the steps here. And the steps is going to be per epoch. And it should be defined as the length of train x and the flow division of BS, which is going to be, and what is BS? Which is going to be the batch size. Okay. Now after, what we need to do, we need the validation data. So we will write validation data. It should be test x, and test y. Okay. Now what we need like validation steps also. So what are the validation steps? So validation steps to be, which is going to be length of test x with the flow division of, which is going to be the batch. Now after that, we need to like pass the input, which we have already started the epochs as in the very beginning, which is going to be which is stored in this particular variable as epoch. And after this, what we need to do, we need to like make predictions of with our model. We train the model. Now the model will make the predictions. It will predict the real life scenarios. So how are we doing this? First of all, using the user message that we are evaluating this network. So first, evaluating the network, we need to evaluate the network. Okay. And let me just define this preceding also, like trading, right? And what it will do, it will call this model function and it will predict, and what it will predict, it will predict the text values and the batch size, like with the batch size. So let's pass the batch size as BS here. And after that, we need to like get the index of these predictions. So the largest predictions would have the index. We need to give them the index. And how will be getting that? So with the same variable that we had. So from the np dot argument, which is going to maxed arg, we need to like pass this index function here. And the axis should be settled to 1. So from the first axis, let's grab this value. And after this, we need to print the report. So let's print the report by, the report will be printed by classification report function, and we need to pass some of the parameters, which is going to be the test y, the test y dot argmax, and which axis, which is going to be the first axis. Okay. And after that, what we need to pass, we need to pass this prediction index also. And okay, now what we need to pass? We need to pass this target name also, and it should be the LB variable that we have made. Now, if you remember what is LB variable defined, it is the label banerizer, which is going to be the label banerizer function. So let's call this function here LB. So LB dot classes. I will be calling this function here. Now after this, like after all the reports is predicted and all the reports is printed, what we need to do, we need to save our model. So let's first save our model. Let's first give the user that it's saving our model. So saving the model. Now after giving the user message, let's save our model. So let's call this model here and call the save function here, and it has a name as mask. So mask detector dot model. So I'll give the name here as name as test and save. Save where? Save in the format should be H5. So this should be in the quotes. So we do not want to miss anything right now. So after reporting all this, saving our model, predicting and making the predictions, getting the largest index and printing the report, what we need to do, we need to plot the loss and accuracy. So by time to time, right, epoch, increasing epoch, we need to lose the loss and we need to gain the accuracy. So that's what accuracy, that's what actual logic of training on data. And how are you using this data? How are you using it? We're using the matplotlib function for that. So let me just give it as PLT. So let's now first jump to that logic. So first of all, the first is gonna be saving is epoch, which is gonna be the n variable, and after that we need to call this PLT function. So PLT, after that the style function, and this style would be use a plot. So which plot it will be using? It should be using with the ggplot. Now after that, that's the style of the plot that we'll be using, and it should be a figure. So plt.fill function should be present here, figure. Now after this, what we need to do, we need to plot the data. plt.plot. So first of all, plot this loss data, which is going to be the training loss data. Side okay. So we'll be calling the np-arrange function, and it will arrange from 0 to 1 and a number of epoch. And after that, we'll be calling h, and if you know what is h, we saved it h here, which is our augmentation data. So which is the place where we trained our data. So h dot history, and history should be of the loss first of all. Okay, and this should have a label. It should have a label, and the label should be train loss. Train loss. After that, what we need to do, we need to same disability. You need to plot for the valuable loss also. So is the training loss. So, so let's go and the val loss here, val loss, and then I'll just change it to the val loss. Now after this, what we need to do, we need to pass this plot this for the accuracy also. So we're just gonna copy this thing and then we'll just paste it here, and let's say to accuracy, and let the label should be train accuracy, and after that val accuracy. Okay, now okay, this is the main val accuracy. After that, what we need to give the title to upload. So PLT, so we're calling PLT title. The title should be training loss, and after this the loss should get lower and accuracy should like get higher. Now after that what we need to like just a label, just gonna show the number of epoch. Now what it will show the name, it's gonna be the page number. After that what we need another label for the loss, the plt.label. Now after that what it will take the like lost value of the accuracy value. Now what we need to do, we need to like save the figure function plt.legion first of all, and the legion will take some of the parameters. It will write to left. After that it will save our model. After like after this we're not gonna like run this because it's gonna take a much time, because there's like too much of data, which is like more than 1,000 images with mask, and with the same more than 1,000 image for like without mask. So after when you like do this, like as mentioned in this video, step by step will we see that it will generate some model like this, and this will, so it will show you the actual training value and the actual training loss, and what is the training accuracy, the loss and all, it will show you everything. So that is it, that is from this particular video. In the next video we'll be continuing this project only, and then we'll be defining the detect mask POI file, and we'll be using the OpenCV function there. And what it will do, it will get the mask from the real life example. So that is from this video. Thank you.